Okay, I left you at liquid mountaineering, true or not. So I'm not going to talk about that because I really want you to watch it and see what you think. Then if you're not sure, look up like Mythbusters liquid mountaineering and see what they said. All right, so we're up to high heat capacity. That means water can absorb heat without a great change in temperature. So it makes areas more temperate that have a large body of water next to it. So that would mean areas of the world that are next to the ocean, but on a smaller scale, if you live next to a lake. I used to live on a lake in Oklahoma, and I could sail every afternoon because there was wind. Why was there wind? Because the water absorbed all that heat but didn't change temperature very much, while the air changed temperature really rapidly. So you had this difference in temperature between the water mass and the air mass, and then we have wind. Today in class, a student did a demonstration where she actually, it's kind of long and involved, but she ended up with these bubbles of gas in her hands, and she actually put her hand in water first, then in the bubbles of gas, and lit it on fire, and it didn't burn her hand. It was pretty crazy because water absorbed that heat energy. Her hands were cold. Don't try this at home, for sure, but it was pretty cool. And it was this concept that she used. She talked about at the end. It was like boiling water in a paper cup. When you put a paper cup in coals from a fire, say, like if you're camping, it's going to boil because the water is going to absorb all of that energy and change temperature, but it won't catch the cup on fire because the water's absorbing all that heat energy. It's pretty cool. Watch that one too while you're watching them. High heat of vaporization. If you're older, you know where this came from. This came from a movie called Airplanes, this picture. But what's happening when you sweat is it's cooling you off. You may have known that. Well, what's happening at a molecular level is the waters come out of your body, you sweat that water out, it's a water molecule, and it takes energy to break those hydrogen bonds so it becomes a vapor and evaporates. And where does it take that energy from? From your core body temperature, so it cools you down. That's called high heat of vaporization. It takes a lot of energy to break those bonds. And it's one of the few things that is less dense when in solid form, when it's ice. What actually happens with those hydrogen bonds, they expand slightly. If you've ever put a Coke bottle in the freezer, sealed up, and forgotten about it, you were going to cool it down and forgot, it'll expand and blow out the end of the jar, whatever it was in probably. That's because ice was expanding because of those hydrogen bonds. Why is that important to life on Earth? Well, if you think of a body of water, that ice on the surface forms a layer of insulation. So all the organisms living underneath there do slow their body down. They have low metabolism because it's so cold, but they don't freeze solid because of that layer of insulation. And how does this relate to our roads? What happens? What makes a pothole? Water gets in these cracks, freezes, expands, makes the crack bigger, and we end up with potholes. So engineers do this really cool thing, like on the sidewalks. Do you see all those divisions that they've made right here and here? These small gaps, so the water can go in there and freeze and expand and not break the concrete. All right, magic of water, all done.